In this section 1.6, we're going to measure the distance between segments on the coordinate plane. So we'll use a midpoint formula, a distance formula, and the Pythagorean theorem to find the distance between 2 points. The midpoint formula, given 2 points here and there on a coordinate plane, to find the midpoint we use this formula. We add together the x coordinates and we take the average, or we divide by 2. We add together the 2 y coordinates and we divide by 2, or take the average. So here we would take 6 plus 3 divided by 2, comma, 4 plus negative 4 divided by 2. And that's how we find our midpoint. So my midpoint, or halfway between these 2 points, is 4.5, comma 0. So you can see where I get my x and my y's from. Negative 1 plus 9, 3 plus 0, and divide both by 2. My midpoint is 1.5. C makes you go in a different order. We know the coordinates for A, negative 2, 3. We know the coordinate for the midpoint, but we don't know B. So one way to do it is to think about how far we traveled to get from negative 2 to 1. We had to add 3 to our x-coordinate. We can add 3 again. So the x-coordinate of B is going to be 4. If we do the same thing for the y, turns out we subtracted 3. So let's subtract 3 again. And the coordinate for B is 4, negative 3. D is very similar. They give us x in the midpoint, find y. So we went plus 4 and minus 6, so we'll follow that pattern. And we end up at 10, negative 5 for y. The next formula we look at is the distance formula, which reads that the distance between A and B is equal to the square root of the difference in x-coordinates squared plus the difference in y-coordinates squared. Do you remember a squared plus b squared equals c squared? That's what we use. We just take the square root of both sides and we replace a with x2 minus x1. And we replace b with, y2 minus y1. And that's how we get this distance formula. So let's see what it looks like. If I was using the Pythagorean theorem, I could draw this into a right triangle. I could count my distance here, that's 2, my distance is 4. I could plug these in like so. 4 plus 16 is equal to c squared. C is going to be equal to the square root of 20. If I use the distance formula, you can see that I end up with some of the same values. In fact, I get the square root of 4 plus 16, or the square root of 20. On the left, it looked a little bit different because we had to take the square root of this to solve it for c. In the distance formula, that radical is always there from the beginning. You can't really use the Pythagorean theorem on this one because there's not a triangle. If you just count over, you'll see the distance is 8. Doing the same thing with the distance formula, I take the difference in x, the difference in y, and I plug them in there. And I get 0 on the right, so if I simplify a little bit, I just get 8 as well. For that one, I think it was easier to count. Here are my 2 points. I can turn this into a triangle. I have a distance of 3 there, and a distance of 5. According to Pythagorean theorem, 5 squared plus 3 squared is equal to c squared. Once I get to this point, I'll take the square root of both sides. They want us to round to the nearest tenth, so we'll leave that as 5.8 is equal to c. You can't count on the diagonal because it's not 1 by 1, so you have to use something like the Pythagorean theorem. Here are my 2 points. Here's my formula, the distance formula. I will take 1 for the second x-coordinate and negative 4 for the first. I'll take negative 2 for the second y-coordinate and negative 5 for the first. If I simplify a little bit, you get the same answer, 5.8. And you should see that 25 and 9 show up regardless of the method you use. The distance formula is just better for when you don't have a graph and you can't see the triangle. Last example, I have side lengths of 1 and 6. According to the Pythagorean theorem, 1 squared plus 6 squared is equal to c squared. If I take the square root of 37 in the calculator and I round to the nearest tenth, I get 6.1. If I plug in my x-coordinates and my y-coordinates, like so, the negatives will go away. For example, negative 1 squared just gives me a positive 1, negative 6 squared gives me a positive 36, and I get the square root of 37, which if I simplify still gives me 6.1.